Hello everyone, welcome back to my channel. Hope you all are doing great and good to see you all here. If you are new to my channel, don't forget to subscribe and hit the bell icon so you don't miss any of my upcoming videos. So, today we are going to learn an important concept from class 9 mathematics chapter lines and angles. In this video, I will explain you the topics like what is a transversal, what type of angles are formed when a transversal cuts two lines, and the special case when lines are parallel, and finally I will explain you and will prove an important theorem, that is, if two lines are parallel to the same line, then they are parallel to each other. Okay, so these are the topics that we are going to discuss in this video. So let us look at each of them one by one. The first topic here is lines and a transversal. Okay, so let's get started. First, we will see what is the definition of a transversal, what a transversal is. Okay, so here as you can see, this is the definition of transversal. A transversal is a line that intersects two or more lines at distinct points. Okay, a transversal is a line that intersects two or more lines at distinct points, and when this transversal cut across other lines, it forms several angles. Okay, and if these lines are parallel, these angles have special properties and relationships. Suppose, let us say we have two lines. Okay, consider this as one line named as A and B, and this is our second line named as C and D. So this is the first line A and B. This is second line C and D. So now let us take an other line named as E and F. As you can see here, this line E and F is cutting these two lines. Which two lines? AB and CD. These are the two lines which are cut by this line E and F. So the E and F which is cutting across these two lines is called a transversal. Okay, so the line which cut across other lines is called a transversal. Okay, this acts as a transversal. So if you take a real life example, now let us understand this transversal topic with a real world example. Think of a railroad track. So as you can see, this is a railroad track. Like in this railroad track, in between we have some wooden ties, right? This is a railroad track, and in between we have some wooden ties in between. Okay, so these wooden ties are like they are crossing the track and they act as transversal here. Okay, in the same way, when the transversal crosses two parallel lines, they form different types of angles. Okay, so as you can see that here, these two rails, this is first rail and this is second rail, these are two rails, and we consider them as these are two parallel lines, and this wooden tie which is cutting them or which is crossing them is called transversal, right? These are two lines and this wooden tie is cutting these two parallel lines or crossing these two parallel lines. This is a transversal, right? So when this transversal line cut across different lines at distinct points, as you can see here, we have one point and here the other point we have. So when it cuts these distinct lines with distinct points, it forms several types of angles. Okay, as you can see here, four angles will be formed. Here four angles will be formed. Similarly, here also 4 angles are formed. So consider two parallel lines AB and CD. As you can see here, we took the line AB and CD, and which is cut by a transversal EF. So this AB line and CD line, it is cut by a transversal line EF. This creates 8 angles. Okay. So this transversal line, when it is cut through these two lines, it creates how many angles? It creates 8 angles, which are labeled from 1 to 8. Okay. Which are labeled from 1 to 8. At point E, so here you can see 2 points. This is point E and this is point F, right? Okay. So this is the top intersection and this is the bottom intersection. So let us consider this point of intersection as P and let this the point of intersection be Q. Okay. So at this point of intersection, which is P, we have 4 angles. So this is your angle 1, this is your angle 2, this is your angle 3 and this is your angle 4. Okay. And this is your angle 5, which is at bottom intersection. At point Q, they also form 4 angles. So the 4 angles here are angle 5, angle 6, this is your angle 7 and this will be your angle 8. Okay. So this is the diagram of how a transversal line cut through two lines with distinct points and form 4 angles. So whenever these lines are crossed, we have some special properties and different types of angles are formed. Okay. Now let us see what are the different types of angles formed. Okay. As we have seen what is a transversal line, now let us see when a transversal line is crossing through two different lines. So this is your line 1 and this is your line 2. This is your line 1, that is A, B, and this is your other line which is C and D, and a transversal line is crossing these two lines at some distinct points. Let that point be P and Q. Okay. There this line, it creates 8 different angles as we have seen previously. Now let us see what are the different types of angles are formed. Okay. So the first angle is interior angle. Let's see what interior angle is. So an interior angle is a angle which lie between the two lines. Right? Interior angle is an angle which lies between the two lines. What are the two lines here? One line is AB and other line is CD. And angles we have are 1, angle 1, angle 2, this is your angle 3, this is your angle 4, this is your angle 5, this is your angle 6, this is your angle 7 and this is your angle 8. So interior angles are angles that lie between the two lines, or you can say the angles which lie inside the two lines. So here as you can see, angle 3, angle 4, angle 3, this is your angle 3, this is your angle 4, this is your angle 6 and this is your angle 6. These 4 angles are lying between two lines and they are inside the two lines. So interior angles are those angles that lie between two lines or inside the lines. Okay. So here angle 3, angle 4, angle 5, angle 6 are interior angles. Right. Next, this is other type of angle which is exterior angle. Let's see definition of exterior angle. So what is a exterior angle? Exterior angle is a type of angle that lie outside of the two lines. Okay. So interior angle is an angle which lie inside two lines and exterior angle is an angle which lie outside the two lines. As you can see here, which are the angles that are lying outside the lines? Yes, they are angle 1, angle 2, angle 8 and angle 7. These angles are lying outside the lines. Okay. Next, corresponding angle. What is a corresponding angle? So this is one more type of angle which is formed. So what is a corresponding angle? Corresponding angle are pair of angles. So in interior angle and exterior angle, the single angles are formed. Okay, individual angles are formed. Whereas coming to corresponding angles, we have pair of angles. Okay, in corresponding angles, we have pair of angles. So in this pair of angles, which is your first angle and which is your second angle? So corresponding angles are those angles that lie on the same side of the transversal, out of which one is your interior angle and other is your exterior angle, right? So corresponding angles are the angles which lie on the same side of the transversal. So this is your transversal E and F. So on this line EF, on the same side, which are the angles? 1 and 4 are on the same side, 5, 8 are on the same side. Similarly, at your right side, angle 2, angle 3 are on same side and 6 and 7 are on same side. So in the corresponding angle, one in the pair, one is your interior angle and one is your exterior angle. So what is interior angle? Which lie inside the line. So as you can see here, angle 4 is inside the line. So out of the pair, one angle is your interior angle, which is angle 4. Now we need which angle? We need exterior angle, right? So the exterior angle here is angle 8. Okay. So they lie on the same side of the transversal and they should not be adjacent. Adjacent means they should not be like side by side. So angle 4 here is interior angle which is inside the line and exterior angle here is angle 8 which is outside the line. So the pair of angle is angle 4, angle 8 which is your corresponding angle. Similarly, see here in this example, angle 5 and angle 1 and angle 5 are the pair of corresponding angle. Look here in the diagram, angle 1 is your which angle? It is exterior angle and angle 5 is your interior angle. So the pair, in pair, one is your interior angle and one is your exterior angle. Similarly, angle 2 and angle 6 is your corresponding angle. Similarly, 3 and 7, 4 and 8. So from the figure, we have 4 pairs of corresponding angle. Right? Next, we'll see some more types of angles that are formed. So here the other type is alternate interior angle. Let's look at the definition of this angle. So, what is your alternate interior angle? Alternate interior angle is an angle that are on opposite sides of the transversal and between the two lines. So, these are your two lines. This is your line AB and this is your line CD and this is your transversal which is cutting this two lines at distinct points. So, we have angles, 8 angles are right. Angle 1, 2, 3, 4 and angle 5, 6, angle 7 and angle 8. So, alternate interior angles are those angles which lie on opposite sides of the transversal and between the two lines. As you can see here, in between these two lines, we have 4 angles. In between this line, we have 4 angles. What are that 4 angles? They are angle 4, angle 3, angle 5 and angle 6. So, in this between, which are alternate interior angle? The angles which are opposite. So as you can see here, in these four angles, which are the opposite angles? Angle 4, angle 6 are opposite angles, and angle 3 and angle 5 are opposite angles. So these are called alternate interior angles. Okay. Okay. Here a simple logic is applied. So alternate interior angles. In alternate interior angles, first uh, see what are interior angles. So interior angles are nothing but the angles which lie inside the two lines. Now apply the text or the topic, that is alternate. So when coming to alternate angles are those angles that are opposite to each other. So alternate interior angles are those angles that are on opposite side of the transversal and between the two lines. Examples, here you can see that angle 4 and angle 6 are one pair of alternate interior angle, as well angle 3 and angle 5 are other pair of alternate interior. Similarly, we have one type of angle. So the other type of angle is alternate exterior angle. This is similar to the fourth one that we discussed, that is alternate interior angle. So here a difference is it is exterior angle. So what are exterior angles? Exterior angles are those angles that lie outside the lines. Okay. So what are the angles here which are outside the line? They are angle 1, angle 2, angle 8 and angle 7 are outside the line. So in alternate exterior angle we have pair of angles, right? So in this opposite side of the transversal and they should be outside the line. Now as you can see here, angle 1 and angle 7 are opposite to each other. So they form one pair, and this angle 2 and angle 8 are other pair which are alternate exterior angle, right? Next, we have consecutive interior angles, or they are also called as co-interior angles. So, angles on the same side of the transversal and between the two lines. Okay, what are co-interior angles? Co-interior angles, in this also we have pair of angles. So co-interior angles are those angles they lie on same side of the transversal. As you can see here, what are the interior angles here? They are 4, 3, 5 and 6. So 4, 3, 5, 6 are interior angles, and in this interior angles, which are the angles that are lying on the same side? They are angle 3 and 6. They are on same side, as well angle 4 and angle 5 are on same side. So angle 3 and 6 is one pair which is co-interior angle. Similarly, angle 4 and angle 5 is other pair which is here one more pair of co-interior angle. Similarly, you have co-exterior angles. We have co-interior angles. Similarly, we have co-exterior angles. So what are co-exterior angles? Co-exterior angles are those angles that lie on the same side of the transversal and they are outside the two lines. Okay, they are outside the two lines. Co-exterior. Okay, so co-exterior are the angles that lie on the same side of the transversal and outside the two lines. So in a pair, see here, what are the exterior angles we have? The exterior angles here are angle 1, angle 2, angle 8 and angle 7. So they should lie on same side, right? So here angle 1 and angle 8 are on the same side and they are outside the line, and similarly angle 2 and angle 7 are on the same side and they are outside the two lines. So this is your one pair of co-exterior angle and this is your other pair of co-exterior angle. So these are the types of angles that we discussed. Next, we'll look at lines parallel to the same line. Okay. Now, this is your one line. This is your other line. And this is your one more line. As you can see here, these two lines are parallel to each other. Okay. So, the concept here is if two lines are parallel to same, if these two lines are parallel to each other, they are parallel to the third line also. Okay. If two lines are parallel to the same third line, they are parallel to each other. This is a fundamental rule in geometry, often called transitive property of parallel lines. So what is transitive property of parallel lines? If these two lines are parallel to each other and they are parallel to the same third line, both these three lines are parallel to each other. Let's say you have three lines. Suppose this is your line A, this is your line B, and this is your line C. Now, as you can see here, this is your line A, and if this line A is parallel to this line C, okay, so this line A, if it is parallel to line C, and this is your line B, and if this line B, just a minute. So, this is your line A which is parallel to line C, and this is your line B which is parallel to line C. Okay, line A is parallel to line C and line A is parallel to line C and line B is parallel to line C. Then it must be true that line A is parallel to line B. Okay, so this is the one property, we call it as transitive property of parallel lines. When two lines are parallel to each other, they are also parallel to other same third line, and all these three lines are parallel to each other. And we have a statement that lines which are parallel to same line are parallel to each other. If this line is parallel to this second line, it is also parallel to third line, and all these three lines are parallel to each other. Okay. Now, let us look at a very important theorem. Here, a theorem is if two lines are parallel to same line, will they be parallel to each other? So, here we need to prove this theorem. What is the statement here? The statement here is if two lines are parallel to same line, these are two lines. If these two lines are parallel to the same line, will they be parallel to each other? Now, let us check this theorem. First, we have drawn three lines. Okay. So, these are three lines. Let this line be L, let this line be M, and let this line be N. Okay. Such that first, we have drawn three lines, right? We have drawn three lines named as L, M, N. Such that line M is parallel to line L and line N is parallel to line L. Now, let us draw a transversal T. This is your transversal T. Let us draw this transversal T on this line L, M, and N. As you can see here, we have three lines L, M, N, and a transversal T is drawn on these three lines. Now from figure, as you can see that line M is parallel to line L. So the corresponding angles, here you will have an angle which is your first angle, this is your second angle, and this is your third angle. As we have seen previously that when a transversal cut across different lines, they form different angles, right? So here when line T, which is your transversal, is cut across these three lines, it formed three different angles: angle 1, angle 2 and angle 3. So from figure, line M is parallel to L and the corresponding angles at line L and M are equal. So what are the corresponding angles here? When line M is parallel to L, the corresponding angles are angle 1 and angle 2. Let us say this as equation 1. Now, we also have line N parallel to line N parallel to line L, and the corresponding angles at L and N are equal. First, we have shown that at line M and L, these both are parallel and the corresponding angles, which are angle 1 and angle 2, are equal. Similarly, we have line N and line L. Similarly, in this, the corresponding angles at line L and N are equal. So, what are the corresponding angles at line L and N? The corresponding angles are angle 1 and angle 3. At line N, we have angle 3 and at line L, we have angle 1. Let us take this as equation 2. Okay. Now, from 1 and 2, you can equalize this both equation, right? Angle 1 is equal to 2, which is your angle 2, and angle 1 is also equals to 3, which is your angle 3. Now, we will get that angle 2 is angle 3. When we solve these two equations, equation 1 and equation 2, you will get an equation that angle 2 is also equals to angle 3. Okay, here is your angle 2, which is at line M, and here is your angle 3, which is at line N. Okay, so hence we prove that if two lines are parallel to the same line, they will be parallel to each other. Okay, if a pair of corresponding angles are equal, then lines are parallel. Okay, similarly here line M and line N are parallel to each other. We prove that line M is also parallel to line N. Okay, so that's all for today's class. We learned what is transversal line and different angles formed when a transversal line is cut across different lines, and we also seen the property of parallel lines. I hope you understood the topic clearly, and if you like this video, don't forget to share and subscribe to the channel. See you in the next class with more interesting topics. Thank you.